Isopentyl acetate, a molecule composed of carbon, hydrogen, and oxygen, smells like bananas. Combustion analysis of 1.750 grams of this molecule provides 1.695 grams of water and 4.142 grams of carbon dioxide. What is the simplest formula for isopentyl acetate? Well, for this combustion analysis problem, the way to approach it is take that water and carbon dioxide data and find the relative numbers of carbons and hydrogens. Since oxygen's all over the place, you can't get it by that sort of approach, but you've got two of the three. You then see how much of the 1.75 grams you've used up, and the rest of it came from oxygen. Turn that into a relative abundance, and you'll have the molecular formula, I should say the empirical formula, for isopentyl acetate, but it needs a lot of cleaning up. It'll be in fractions. To clean it up, step 1, divide by the smallest number, and then step 2, scale it up to get whole numbers. Okay, that's the procedure. Here we go. We have about 1/10 of a mole of carbon dioxide, and since it's 12 grams per mole, we must have started in the original sample with 1.13 grams of carbon. We're going to use that to find out the remainder, which is oxygen. Going back, we see that it has a relative abundance of 0.094 for carbon. Let's do the same for the hydrogen. This follows the same procedure. 18 grams is a mole, but of those 18 grams, 2 came from hydrogen. We're getting these numbers from the periodic table, average atomic masses. And so we have then used up 0.1897 grams of our sample, but not the whole 1.75. Proceeding on to its molar fraction, we get a number of 0.1882. It looks like a ratio of 1 to 2 for carbon to hydrogen. Good. Now the rest of it must be oxygen. So we had 1.75 grams. We've accounted for some of it, but we still have 0.43 grams remaining. Dividing by its molar mass, we get the relative abundance of oxygen. That's a typo right there. That should be an oxygen. And when we take those and try to clean them up, there it is cleaned up. There's our oxygen. We divide by the smallest number, and that'll give O as a 1. And oh, I love the way this turns into half a number. It should be clear to you that we need to double everything. And the empirical formula for isopentyl acetate is C7H14O2. I believe it's also its molecular formula because there it is there. 1, 2, 3, 4, 5, 6, 7 carbons, for example, with these silly banana bonds. Okay, that is the empirical formula of isopentyl acetate.